where are the post-truths or the false claims, and where are the facts in this. The first limit of machine learning that we know of and that we have learned over the years that we are experimenting with is the training set. The first thing, you need a large training set, and it has to be correctly labeled. So in case of cybersecurity, you need to have a lot of files, a lot of URLs, and you need to have them labeled as clean, malicious, and let's say potentially unwanted. So something that's not really malicious, but it's not really good. And if they are not correctly labeled, then even the algorithm isn't going to be able to learn how to sort them right. Now, what often happens, we see 300,000 new samples every day. That's a lot, and often there are some that are not similar to any other malware that we have seen or any other clean software that we have seen before. And that's the crucial part. Now the machine learning is on its own, and it should be able to say, okay, this is good, this is bad, or this is gray area, so I'm not really sure, or we need to do something with this. If it doesn't, or if it does and does it wrong, it can happen that it's going to be a false positive, or actually it can be even worse. It can miss a malicious sample and let it through, so it will cause an infection. That's why we need humans still in the equation, so they will check for those things that are not 100% correct, or it's hard to say what they will do, and humans have the experience to say that. So if somebody claims they don't need humans in the equation, that's not true. We are not there yet. Then there is the second claim they use. We can detect any malware without running it. So pre-execution. We can actually say without running the malware in some kind of the experimental environment, as a sandbox or in some way, it's really hard to say if it's going to do something malicious or not. We know that because Alan Turing, which you might know for breaking the Enigma code during the World War II, and as a father of computer science, he has proven that this is impossible. So by looking at the malware, it's impossible, or at the sample from outside, it's impossible to say what it does. How did he do it? He designed an experiment that said, okay, we have a machine that can always rightly say if the program that we feed it with some input, if that program will halt, or if it will stop, which is good, or give us some result. Okay, we don't know how the machine works. We actually don't really care that much because we know it's always right. So let's keep it that way, and let's try to play with it a little bit. That's what Alan Turing did, and he came up with this little small change, a little bit that he added that opposed the normal results that the machine would give. So if it said, okay, this program with this input will work, so yes, it would oppose it and would say it will loop forever. If it said this program won't work with this input, it should have said it will loop, but it will stop. Now he put this in another, let's say, he enclosed it into another machine that he called the machine plus, and he fed it, we wouldn't guess that, but with itself as the program. So the machine plus would be considering if machine plus would work with machine plus as its input. What happened? It would say, if it would say it would stop, the reality would mean it would loop forever. So it was wrong. On the other hand, sometimes it would say it would loop, but in reality, it would stop and give you a result. So it was wrong again. But shouldn't it be right all the time? So you can see that that's the proof that that's impossible to have a machine that will always tell you the right answer for each question. And that goes also for malware and malicious things that are hiding out there and posing as clean items. So another limit to machine learning is the intelligent adversary. So you are not standing against machines, you are not standing against some simple rules, you are standing against an intelligent human being on the other side. And the bad guys, so the black hat hackers, often know what the rules of the game are. So they are trying to bend them, to circumvent them, to change the things that are in the gaming field so that they will win. That's the same for facial recognition or for self-driving cars. It's not really hard to manipulate the environment to make the machine learning algorithm a wrong decision. Now, we are talking about things that are, okay, self-driving cars. I don't think that there's so many people running around covering the signs. But when we are talking about malware, we are talking about people who are constantly, every day, working on new malware types that are able to circumvent security solutions. They are finding new ways how to get into the computers of companies and of the normal users. So it's really a cat and mouse game every day. Another limit of machine learning, or let's say the claim that the next-gen companies are doing, is that they don't need updates. Now, what would that mean for a solution? If you have no updates, you have no global context. So you don't know what's going on in China, you don't know what's going on in the United States, you don't know what the computers in the network see and elsewhere in the world. So you don't know if the thing that came into your computer is bad or good. Even though thousands of computers maybe saw it before and they already know and they have the answer, but they won't give it to you because you're not connected. You don't have the updates. Similarly, if you don't have updates, you need to evaluate every sample for yourself. So that means you need to use more hardware resources and it will drain your power. So it's another cost that you have on top. Without updates, you will also have more false positives because even if you are good at evaluating those things that you are receiving, in the end, sometimes there will be some mistakes, and those will be mitigated by the number of other people in the network that will give you information. So more false positives will be happening, of course. Without updates, there will be also less accurate detections. Less information means less accuracy, so that's pretty straightforward. Without updates, there is also no fix for the errors. So if the algorithm is doing wrong decisions and nobody is telling it, okay, this was a wrong decision, you need to fix it, it's going to loop forever and it will be feeding itself with the same bad decision, making it worse with each and every step. And also with no updates, you have less information for the machine learning. And as I said before, you need a lot of data to train it right. So this is something that you will be also missing. And the limit number 5 is false positives, of which importance is often downplayed by these new players in the game. When they are saying, okay, you don't need to care for false positives, actually that's not that big of an issue. We can tell you from our own experience that machine learning is not really able to classify everything correctly. So it's by its design. It's more aggressive than the human being that's really looking at the samples and the analysts that are working with it for years. So it's more probable that there will be a false positive coming up. And if that happens more often, then this can have negative results for your IT staff and administrators. Some of them will be chasing ghosts, which is wasting human resources and also money. Or, as I said before, the purely machine learning-based solution might lack the context. So this would mean that you need to invest more hardware and more power into evaluating everything. And in the worst case, if there are too many false positives, they will get ignored at some point because even the humans who would be handling all those false positives would grow wary at some point. That's for sure. So what we can say about false positives, if you look at if some malware gets into your system, it may break your business. Let's say, for example, ransomware. But if you have a good solution, it can be cut off at some point, some stage of the infection, or even of its malicious activity, it can be cut off. False positives, on the other hand, will surely break your business, because if your OS files or some important URLs are blocked, then the whole system might get broken down. If you look at some manufacturing plants or, let's say, manufacturing lines, building cars or something, if something bad happens to their operating systems, you can bet that the damage is going to be bigger than some ransomware infection.